Welcome to today's lecture. Today's lecture will still be on radioactivity, part 9. Today we'll be looking at artificial radioactivity. Artificial radioactivity is also known as artificial transmutation. Artificial transmutation is the bombardment of the nucleus of a non-radioactive element with particles like beta particle, alpha particle, deuterium, neutrons, protons. Now we need to get a symbol or recall some of these symbols that are used to represent beta particles, alpha particles, deuterium, neutrons, and protons. So for beta particles, we represent beta particles by using E 0 minus 1. We're familiar with alpha particles and beta particles from our previous lecture. So alpha particle is 42E, that's helium nucleus. Deuterium is 21H. Neutrons 10N. Protons 11P. We are required to commit these particles to memory. Now, of all these particles that are listed here, the neutrons are the most effective. They are the most effective because they are not charged. In other words, they are not charged particles. They are neutral. So when you use the neutron to bombard the nucleus of an atom, it does not encounter any form of repulsion or attraction. So let's look at them. Beta particle, negative. Alpha particles, positive. Deuterium, positive. Protons, positive, but the neutrons are neutral. Of all the particles used for the bombardment of the nucleus, neutrons are the most effective because they are neutral, hence they do not encounter any problem of attraction or repulsion from the nucleus. So let's see simple examples. We're given sodium, X, fluorine, and alpha particle. Of course, we're told to find the particle X. What particle is X? So sodium, 2311. We'll have to assign the nuclear number and the proton number to X, which is AB. And of course, alpha particles are helium nucleus, remember, 42He. So then we consider the atomic numbers first by adding them and equating to this other side. That is 23 plus A is equal to 20 plus 4. So A plus 23 is 24. So A is 24 minus 23. A is 1. Then after then you consider the proton number, which is also called the atomic number. 11 plus B is equal to 9 plus 2. That is 11 plus B is equal to 9 plus 2. So 11 plus B is 11. So B is actually 0. So if we'll put the values we got, the X, AB becomes 10N X, which is similar to 10N. So it means that X is a neutron. So we look at question 2. For question 2, we're given nitrogen, tritium, oxygen, and X. They were told what particle is X. Of course, just like what we just did, not quite long, we take the mass numbers after assigning A and B as the mass number and proton number, atomic number for X. So 14 plus 3, the R, which is equal to 16 plus A. 17 is 16 plus A, so A is 1. Then we take the atomic numbers. 7 plus 1 is equal to 8 plus B. So then 8 is 8 plus B, eventually B is 0. Again, AB then becomes 1, 0. Since A is 1, B is 0, and it looks like the neutron. So X is a neutron. The last question, question 3, we're given 2311 sodium plus neutron going to fluorine plus X. What particle is X? So we interpret the question. 2311 Na, neutron is 10N, 29 plus X, assigning A and B as the mass number and proton number. Then we look at all the mass numbers. That is 23 plus 1 equal to 20 plus A. So 24 is 20 plus A. When you resolve properly, A is 4. Looking at the atomic numbers now, 11 plus 0 is equal to 9 plus B. 11 plus 0 equals to 9 plus B. So 11 is 9 plus B. B is 11 minus 9. So B is 2. So if you put the values there, it looks like helium. And so helium, a representation of alpha particle. So X is an alpha particle.